Welcome to the video on vector products. So a vector or cross product is when you do A cross B, and that's equal to the magnitude of A times the magnitude of B times the sine of theta times the normal vector, where theta is the angle between A and B, and n is the unit normal vector whose direction is given by the right-hand screw rule, which we'll learn about in the following slide. So if A is this and B is this, this is how you could find your cross product. So you would find your determinant of your 3 by 3 matrix, where you have your I, J, and K vectors, and then your X, Y, and Z for your A vector, and your X, Y, and Z for your B vector. So for example, if A was equal to 3, 2, 1, and B was equal to 1, 2, 1, then we could do our cross product by doing the determinant of I, J, K, and then we'll have our A matrix, 3, 2, 1, and then our B matrix, 1, 2, 1. So then we do the determinant of that by splitting into 3 separate matrices. So your first matrix, you'll look at your I times this square here. So it would be 2, 1, 2, 1 times I, and then we're going to subtract J. So for our J1, we'll cross out our J column, so we'll have 3, 1, 1, 1. So it would be 3, 1, 1, 1, J, and then plus K. So for K, we'll get rid of our K column, so we'll have this square over here. So it would be 3, 1, 2, 2, K. So for our determinant, we'll go across like this. So we have 2 times 1 minus 1 times 2. And then we'll do that times I minus 3 times 1 minus 1 times 1 J plus 3 times 2 minus 2 times 1 K. So we can go ahead and simplify that. 2 times 1 is 2 minus 1 times 2. So 2 minus 2 is 0. So we have 0I minus 3 times 1 is 3 minus 1 times 1. So 3 minus 1 is 2 J. 3 times 2 is 6 minus 2 times 1, which is 2. So 6 minus 2 is 4. So plus 4K. So this right here is our solution. So we can write that as a vector 0, negative 2, 4. So this would be our cross product. So now we have our right-hand screw rule, which helps us figure out the direction of our normal vector. So you would start by lining up your right hand with the first vector. So if you had V cross W, you'd line your right hand up with V. And then you want to roll your hand the shortest distance to the second vector. So we're crossing it with W, so the shortest distance is this way. So when we twist that way, our thumb points up out of the page. So that would be the direction of your normal vector. If we were doing W cross V, we would line our hand up with W and twist it the shortest distance to V. So we need to go this way. So we'll turn our hand around and twist it to V, and our thumb is pointing down into the page. So our normal vector would be down into the page. So that's what our right hand screw rule is and how to figure out the direction of your normal vector. Now we have our cross product rules. So V cross W is the same as negative W cross V. So when you cross them, they'll be opposite directions like was shown with the right hand screw rule. So that's why you have this negative here when you do the cross product in the opposite direction. Your U cross V plus W is the same as U cross V plus U cross W. K times V cross W is the same as K times V cross W. And V cross V is 0. And for non-zero vectors, if W cross V is 0, it means that the vectors are parallel. So these are important rules to remember. So now we have our geometric interpretation of the magnitude of A cross B. So the magnitude of your A vector crossed with your B vector is going to be your area here. So that's what that means geometrically. So if you wanted to find the area of a triangle formed by vectors a and b, it would be this area here, so it would be 1/2 the magnitude of a cross b. So that's for your triangle. So here we have our first IB practice question. It says, given that u equals 2, 1, 3, and v equals 1, -2, 4, and w equals 2, 7, 1, find u cross v plus w. So this is one of our rules. U cross v plus w equals u cross v plus u cross w. So doing the cross product is a lot more difficult than just adding vectors. So the easiest way to do this is this first part here. So we'd have our u vector, which is 2, 1, 3, crossed with v, which is 1, -2, 4, plus w, which is 2, 7, 1. So we'll start by adding. So then we'd have 2, 1, 3, cross. 1 plus 2 is 3. -2 plus 7 is 5. And 4 plus 1 is 5. So we need to find the cross product of these two vectors. So we'll have our I, j, and k. And then we have 2, 1, 3, and 3, 5, 5. So this will equal I times, we'll block our I column and row. So the things that are going to remain are going to be our 1, 3, 5, 5. Then we do minus j. If we block our j column and row, then we have 2, 3, 3, 5. Plus k, we'll block our k column and row to get 2, 1, 3, 5. So we'll have I times 1 times 5 is 5, minus 3 times 5 is 15, minus j times 2 times 5 is 10, minus 3 times 3, which is 9, plus k times 2 times 5 is 10, minus 1 times 3 is 3. So we have I times -10 minus j times 1 plus k times 7. So we have -10 I minus j plus 7k. So as a vector, our answer is -10, -1, 7. So here's your solution to this question. Finally, we have our second IB practice question. It says, given that v equals -2, 3, 6, and w equals 4, -2, 5, find 3v cross w and v cross v. So our 3v cross w, we could do our 3v first, or we could do 3 times our v cross w. So let's just go ahead and do it this way. Either way would work. So we have 3 times -2, 3, 6, cross w, which is 4, -2, 5. So 3 times these would give us -6, 9, 18, cross 4, -2, 5. So we'll have I, j, and k. And then our values in here are -6, 9, 18, and 4, -2, 5. So this will equal I times the determinant of 9, 18, -2, 5, minus j times the determinant of -6, 18, 4, 5, plus k times the determinant of -6, 9, 4, -2. So we'll have 9 times 5 is 45, so it's I times 45 minus 18 times -2 is -36, so it turns into plus 36. Then we have minus j times -6 times 5 is -30, minus 18 times 4 is 72, plus k times -6 times -2 is positive 12, minus 4 times 9, which is 36. So this gives us 45 plus 36, which is 81i. And then we have -30 minus 72. the inside part here would be negative 102, and then it's a negative that, so plus 102j. And then for k, we have 12 minus 36, which gives us negative 24. So minus 24k. So our vector would be 81, 102, negative 24. Now for v cross v, it should be 0, because that's what one of our rules stated, but we can double check that. So we'll have negative 2, 3, 6, cross negative 2, 3, 6. So we'll have I, j, and k, negative 2, 3, 6, negative 2, 3, 6. So this equals I times the determinant of 3, 6, 3, 6, minus j times the determinant of negative 2, 6, negative 2, 6, plus k times the determinant of negative 2, 3, negative 2, 3. So our left and right columns in each of our determinants match each other. So we'll always have something minus that same thing. Like here it would be 18 minus 18, negative 12 minus negative 12, negative 6 minus negative 6. So those are all going to be zeros. So our vector is 0, 0, 0. So these are our answers to this problem. In summary, our vector product, A cross B, is given by all of this information. Our right-hand screw rule is when you roll your right hand to figure out the direction of your normal vector. These are our cross product rules that are important to know. And A cross B, the magnitude of that is equal to the area of the enclosed parallelogram. That's all for this video. Thank you for watching.